Okay, example 4. Prove that the limit of x tends to a of x to n minus a to n divided by x minus a is equal to n a to n minus 1, where n is a positive integer. Yes, now to prove that the limit of x tends to a of this function is equal to n a to n minus 1, where n is a positive integer. And proof. Given lim of x tends to a of x to n minus x a to n divided by x minus a to be equal to n a to n minus 1. Now we consider the left hand side. This is our left hand side. Now lim of x tends to a x to n minus a to n divided by x minus a. Now let x equal a plus h. Now if you look at this function, it raised to the power of unknown n, and a here is a constant because it's the point at which the function tends to the power of n. So this is a variable. So now let x equal a plus h. We call this one equation 2. Let's call this one equation 1. So you now substitute x equal a plus h in equation 1. So this implies lim x tends to a of x to, because x is equal to a plus h. So instead of writing x, we now write a plus h. So we write this minus a to the power of n divided by x minus a is now equal to, now if you say x tends to a and we are saying x is equal to a plus h, now the limit is now as x tends to, as h tends to 0, because from here you say x tends to a and x is equal to a plus h. So if x is a, you now have a equal to a plus h. So if you collect like 10, you have a minus a, which is h, and h is now equal to 0. So h tends to 0. Or this function x is equal to a plus h, you now write a plus h for this one to the power of n minus a divided by x minus a. Our x is a plus h. Now write a plus h minus a. Yes. So this is now equal to lim of h tends to 0 of this function a plus h to the power of n minus, this is the power of n, please, minus a to the power of n, a minus a will go divided by h. Now from here we apply binomial theorem. We know that x plus y to the power of n is equal to x to the power of n minus r, y to the power of r, n combination r, where n combination r is equal to n factorial divided by n minus r factorial r factorial. So we shall be applying this in this function. So this implies lim of h tend to 0 of a plus h to the power of n minus a to the power of n divided by h is now equal to lim h tend to 0 of, now here opening using binomial, we have a to n h to the power of a to n minus 1 h to the power of 0 h to n minus 0 h to the power of 0 n combination 0. That's a start counting from 0, 1, and so on. So start from 0. So a to the power of n minus 0 h to the power of 0 n factorial n combination 0 plus a to the power of n minus 1 h to the power of 1 n combination 1 plus a to the power of n minus 2 h square n combination 2 plus, and so on. So let's put this one in bracket, minus a to the power of n, minus a to the power of n here, then the square bracket will come, everything divided by h. We'll now open this. So now this is equal to lim h tend to 0 or this function. Now a to the power of n minus 0, we have a to the power of n, h to the power of 0 is 1, so you know it's done. Dot n combination 0, you have n factorial divided by n minus 0 factorial 0 factorial plus, here you have a to the power of n minus 1 h, n combination 1, you have n factorial divided by n minus 1 factorial 1 factorial plus, you have a to the power of n minus 2 h square, n combination 2, you have n factorial divided by n minus 2 factorial 2 factorial plus a minus a to the power of n, close bracket, divided by h. Okay, this is lim of h tend to 0. You have a to the power of n factorial divided by n minus 0 factorial will give you n factorial divided by n factorial. 0 factorial is 1, so times 1, so the factorial cancel factorial, so you left with what? A to the power of this. It's okay. Now write n to the power of n factorial divided by n factorial. So this will cancel this because n minus 0 factorial, you have this, plus you have a to the power of n minus 1 h. Now n factorial divided by n minus 1 factorial. So n factorial can be written as n into n minus 1 factorial divided by n minus 1 factorial. 1 factorial is 1 times this still gives you this. So why are we expressing in this form? We want to cancel the denominator. So the numerator can now cancel the denominator here. Plus a to the power of m minus 2 h squared. Now n factorial here we have n minus 2, so we have to carry it up to 2 times. This is n into n minus 1 n minus 2 factorial divided by m minus 2 factorial 2 factorial plus so on minus a to the power of n, close your bracket. Now everything divided by h. Everything divided by h. This is another page. Now this is equal to h tend to 0 as a limit of h tend to 0 of a to the power of n, because a to the power of n, because n divided by n is 1, plus a to the power of n minus 1 h times n, because n factorial cancel n factorial, plus a to the power of n minus 2 h squared n into n minus 1 divided by 2 factorial, because n minus 2 factorial cancel n minus 2 factorial, plus I put this one in bracket minus a to the power of n, put this one in square bracket divided by h. So this is now equal to lim of h tend to 0. Now a to the power of n, a to the power of n, you have a to the power of m minus a to the power of n plus a to the power of n minus 1 h n plus a to the power of n minus 2 h squared n into n minus 1 divided by 2 factorial plus that order, everything divided by h. So this is lim h tend to 0. Now a to the power n minus a to the power n is 0. You now have n h a to the power n minus 1. Multiplication is commutative, so it is same thing as n h a to the power n minus 1 plus n into n minus 1 divided by 2 factorial a to the power of n minus 2 hn. You write this one first, this one second, the same thing, plus in this order divided by h. Now if you look at this, each term contains h, so factor out the h. This is equal to lim h tend to 0 of h into n a to the power of n minus 1 plus factor the h, you have this here, n into n minus 1 divided by 2 factorial a to the power of n minus 2. Now here you have h squared from here, So you now have h. When you factor the h, you have h standing alone. Hn plus, put in brackets, and then close it, divided by h. So you decide that the h will now cancel this. Is equal to lim h tend to 0 of this function n a to n minus 1 plus n into n minus 1 divided by 2 factorial a n minus 2 h n plus, and so on. So you now take the limit of each term. Lim of h tend to 0 of n a to the power n minus 1 plus lim of h tend to 0 of n into n minus 1 divided by 2 factorial a n minus 2 h n plus, and so on. So you discover that there's no term in h here. It means a n to n minus 1 is constant, and the limit of any constant is a constant. So write n a to n minus 1 plus, once h tends to 0 in this function, 0 is multiplied by everything, this gives you 0, plus, and so on. So this is equal to n a to the power of n minus 1. Let's say therefore the lim of the function x tend to a of x to the power of n minus a to the power of n divided by x minus a is equal to n a to the power of n minus 1 as required. That is how we're asked to show from our question. We have to show that the limit of this as x tends to a is equal to n a to the power of n minus 1 as shown here. This is our question that prove that the limit of x tends to a of x to n minus a to n divided by x minus a is equal to n a to n minus 1. Say where n is a positive integer, and we have succeeded proving as shown here. Thank you very much.